Good morning. You know, it's interesting to be bookended by a president who's a music producer and a juggler. Poor professor, you know. Come on. I want to say really quickly that lighting, the electric lighting that we have in here, uses about 20% of that electricity that we just heard about. And we do that because we work in dark places. We live in dark places. Can everybody take a deep breath? I can hear the air go in. You know that breath of fresh air? Have you sensed this room breathe today? Breathe with light? Have you seen the light level just sort of go up and go down? Have you looked around and noticed that this surface over here is brightly illuminated by this south window, and this surface isn't so bright because it's north? And rooms breathe with light, and we breathe with light. We have to breathe daylight. We need daylight. We're entitled to daylight. It's endemic to our health and well-being. Thank God we haven't created a dosage of daylight. Daylight is endemic in every landscape. I'm naturally from Iowa. When I go over the Palouse, when we first moved here 30 years ago, my wife and I, into the Palouse, it was like coming home. It was that light, it was the horizon, it was the sky, it was those big puffy clouds, sort of out of the darkness and into the light. You know, those landscapes are a part of us. That light is a part of us. We need to learn how to read those landscapes as architects, as owners, and we need to know how to take their measure to understand what runs those landscapes. Just like a really great professor of mine, Jerry Diethelm, said years ago from landscape architecture, is that to be a good architect, to be a good owner of a building, you have to be like a sailor sailing the sea. You have to learn to operate and understand that landscape of earth or sky. Take the measure of the sky, understand its rhythms and its patterns, and build and live within those patterns. We have a nature of trying to simplify things, what I would describe as commodify things. These Japanese farmers, this is just such a great picture of taking something that's sort of a little too non-uniform and a little too hard to ship, and maybe we could grow it in a bottle and make it square and make it easier to ship. Well, we've done the same thing with lighting. We need electric lighting. We obviously function in times when there is no daylight. But on the other hand, do we really need the complete commodification of light into a light bulb? Let me digress a minute. Let me talk a little bit about Iowa and that landscape and sort of integrate with some of the things we've heard today. When I grew up in the 1950s and 1960s, I was living off and on in the sort of Great Plains in the northern Midwest, spent a lot of summers at my grandparents' farm, which had been homesteaded by my great-great-grandfather, the doctor, the farmer, the warrior, the army guy, who immigrated there from Michigan in the 1870s. And I knew that farm 75 years later. We would go out and pick corn. We had a farm that had cows and pigs and chickens. And we grew corn and oats and a lot of hay. It was 120 acres. It was a big farm at the time, now a little farm. And when we'd take our single-row corn picker out there and pick those ears of corn, every now and then, ears like these would show up. And my grandfather used to call these Indian corn. And they'd be either thrown away or they'd be bundled up and taken inside for Halloween. And this was the landscape that I knew. This sort of gardened landscape of the Great Prairies. I really had no idea what it was originally, but very quickly, my ancestors hybridized corn from those early strains of maize, Mesoamerican maize, into hybridized corn, which doesn't look that much different, frankly, than those watermelons we saw. Very uniform, very functional, produced at about 25 to 30 bushels an acre. My kids, when we would go back to the farm 20 years ago, they knew corn as that stuff on the right. They knew fruit, really. They knew sweet corn. They thought all corn was sweet corn. Well, we know, when I grew up, we grew corn, we would harvest it early, and that was the corn you'd eat on the table, but it was field corn. So now my kids really know corn. Most people know corn as niblets and kernels and bags of corn, kind of like the light bulb we see over there. Now what do we have? We have, corn on steroids, literally. It's gone beyond hybridization. It's gone way, way into genetic modification. We use corn because of its miracle genetic and molecular structure to be able to be made into all sorts of things. It's plastic, it's sweetener, it's fuel. Corn is everywhere, and it's grown now on our farm at 250 to 350 bushels per acre. It's this sort of rationalized landscape that has grown from when my great-great-grandfather moved there to what you see on the far left. It was really a wetland that was cultured, agricultured, drained, organized, made efficient, gardened, and turned into this really industrially productive landscape. I'd like to go back to buildings. And what have we done to buildings in that same time period? We look at historic buildings, buildings prior to the 20th century, and dominantly they were 5 or 6 stories tall, they were thin, they had small windows. They were thin, why? Because they needed fresh air and they needed daylight. After the turn of the 20th century, buildings became taller and taller and taller. Windows got bigger and bigger and bigger. People got more and more displaced from the landscape. We became more and more urbanized. Buildings got fatter, sort of like some of us have gotten a little fatter. We have moved further and further away from the windows in buildings. We depend on mechanical systems to provide fresh air. We depend on electrical lighting systems to provide light. I've even heard that we're going to take away the need for a window in a bedroom because we can provide safe exit through a fire-rated corridor, we can provide ventilation mechanically, and we can provide an emergency light like we do in commercial buildings. So what do you need a window for? That's a rationalized landscape of building construction. We know the optimum places in buildings, the places where most people want to be, are close to the windows. When you go into these buildings that have deep floor plates, the World Trade Center was a perfect example of that. It was a really incredibly important structural ground because it had very few intervening columns and very long spans from the perimeter to the core, which allowed people to be sort of packed into high-rise buildings, if you will. When you go into these places where you get open space planning, I swear you can see the curvature of the earth, so the partitions sort of do this, and the windows are tiny little things off on the horizon. We've disconnected people from the things that really make our lives livable. How can we replace sunshine in the spring in Seattle? You can't. You can't package that. We now know why. We knew this intuitively. We knew that there are photobiological effects of light. We just didn't know the science of it. In the last 10 years, as recorded in this May 2011 article in Scientific American, the whole science behind vision and the non-visual effects of light has changed in the last 10 years. It's a great article to read. Let me delve into it just a little bit. We as humans evolved in an environment of bright in the daytime, dark at night. Now we live in an environment that is generally dark at night, sort of, maybe, maybe not. TV's on too much, street lights are on too much. Dark in the daytime, except for little bursts of light when you come into work and you go to lunch and you go home. That is, if you don't live in Seattle and it's dark when you go to work and dark when you come home, in the wintertime. So there is an asymmetry between the way we evolved in terms of light and the way that we live in terms of light. What are some of the problems that grow out of that? Well, we have a great incidence now of lower bone density. And we now know, well, we've known for quite some time, that that's related to how our skin absorbs UVB range. Because UVB on our skin gives us the ability to synthesize vitamin D. Vitamin D gives us the ability to produce calcium, which strengthens our bones and our teeth. Here you can see, this is actually in Siberia. And this woman is exposing little kids to this UVB generator to make them healthy. And I'm sure she's dead. She's, poor woman having to do that. But so how do we get our packaged sunshine? We get it as additives to our foods because we're not getting exposed to enough light. But this is light on our skin. Could come in a pill, could come in a drink. Vitamin D fortified milk. Makes sense? How about the woman who has seasonal affective disorder? How many of you feel more depressed in the wintertime? Usually about 20% of the population north of the 45th degree parallel have seasonal affective disorder of some form or another. Some of it is genetic related, some of it is light related. This woman is getting a stimulus of light to her ganglion cells, which we never even knew received light 5 years ago. And that feedback, that neuronal pulse goes back to our suprachiasmatic nucleus, which regulates our hormonal cycles. So think of it as a little pill of sunshine here. We need that intensity of light. Turns out it has to be blue light. Turns out it has to be in the morning. That's the dosage issue. The ironic thing is she's sitting next to this light box and probably getting 3 to 10 times the amount of light from the window she's sitting next to. So our work environments, the places that we spend those 8 hours a day. This is a picture of an office space. If you look at the left image, attorneys on the windows, perimeter. None of them were in their offices at the time. And all their staff assistants are on the right, no windows. And we know through Judy Heerwagen's week, Dr. Heerwagen's work at the University of Washington, that people compensate when you're in environments like that. And commonly they place pictures of nature that can connect them to what they've otherwise been disconnected from. Buildings don't have to do that. Urban environments don't have to do that. Cities don't have to do that. This is a terrific building, one of those LEED buildings by Weber Thompson. This is the Terry Avenue office building. First building built in Seattle since the 1950s without refrigeration or air conditioning. It's very thin. You can see the distance across this footprint is about 30 feet. It's what we think of as an atrium building, has a hole in the middle, which allows light to come deep into the space like this skylight would theoretically do. And the distance from that atrium to the outside wall is no more than 30 feet. So this is a great thin building. This is the way buildings used to be built. This is two pictures of two cities of nearly identical densities. And we're all caught up in this issue of what is the form of the city of the future? And I think most of us are stuck on the idea that it's Manhattan. It's tall buildings. We're all going to live sort of disconnected. That's what you see on the left. This is Manhattan. It's actually Lower Manhattan. It's really the East Village, West Village, something like that. And it has a density of about 70,000 people per square mile. On the right, it's really a city of the 20th century, 19th and 20th century. On the right, what city is this? Paris. That's right. A city of 60,000 people per square mile. A density almost equal to Manhattan. And look at the building forms. You can see it here. These are all thin buildings. These are all 5- and 6-story buildings. And they're organized that way because of the tradition of light and air. So what is Seattle? What's our future? Irvine Ranch on the left, almost the same density as we have. Seattle, 7,000 people per square mile. Irvine Ranch, 4,000 people per square mile. Big fat buildings, big open space, little tiny houses, lots of freeways running around. Hopefully that's not our future. Hopefully our future has a dose of daylight in it. Thank you.